How to write numbers in scientific notation. First, what is scientific notation? Scientific notation is a way to write very large or very small numbers. Very large number would be like the distance to the sun, or a very small number would be something like the weight of a cell. When a number is in scientific notation, it is a number greater than or equal to 1 but less than 10 times 10 to a power. For example, 5 times 10 to the second power is an example of a number in scientific notation. 1.12 times 10 to the 8th power is another example of scientific notation. And lastly, 6.7 times 10 to the negative 12th power is also an example of a number in scientific notation. We're going to take some time to explain what these numbers mean and how we come up with them, but first let's just make sure we can determine or identify if a number is in scientific notation or not based on the definition. One little side note is on some of your calculators, if you are calculating something that becomes too large or too small, there's too many decimal places or too many place values in the number, you might have seen scientific notation before on your calculator, but it's often not written the way that I just explained. It's often written with the letter E in place of the times 10, because the letter E in math means base 10 or times 10. So you might have seen this on your calculator before. Some calculators show the whole thing, some calculators do not. So let's take a look at some examples. Yes or no, is this number in scientific notation? This first one is in scientific notation because this number is greater than or equal to 1 but less than 10 times 10 to a power. This one is also in scientific notation because this first number is greater than or equal to 1 but less than 10 times 10 to a power. This one is not in scientific notation because this number in front is greater than 10. This number is also not in scientific notation because this is less than 1. This one is also not in scientific notation because it's not 10 to a power, it's 100 to a power. Let's take a look at what it means to interpret a number that is in scientific notation. So we are going to look at numbers that are in scientific notation and turn them into standard form, which is the regular format that we are used to seeing numbers in. So when you are seeing a number in scientific notation that has a positive power, the rule is that the power is the number of times that you multiply the first number by 10. Or it's also a shortcut is the number of times the decimal moves to the right. That many places. Let's take a look at some examples. 6.03 times 10 to the 4th power. This means 6.03 times 10 4 times. That is 60,300. Another way to do this without a calculator is to just take the decimal point in the original number, 6.03, and move it 4 spaces to the right, adding in zeros to any of the empty spots that we see. Again, for an answer of 60,300. Let's try this example, 1.45 times 10 to the 7. This means 1.45 times 10, 7 times. Of course, you can do that on your calculator, but sometimes if the number is too big, the calculator will give you the answer back in scientific notation. So this becomes 14,500,000. Without multiplying by 10, a shortcut is moving the decimal to the right 7 spaces. 1, 2, 3, 4, 5, 6, and 7. For again an answer of 14,500,000. But what if the exponent is negative? This means instead of multiplying by 10 the number of times, we're actually dividing by 10. So it's not a negative 10, which is a common misconception. It's that we're dividing the number by 10 that many times, or we're moving the decimal to the left that many spaces. So the number is getting smaller, but it has nothing to do with negatives. So this is same problem as the first one, but instead of a positive 4, we're talking about 6.03 times 10 to the negative 4. So we're going to divide 6.03 by 10 4 times. That's 0.000603. Or another way we can do this is by moving the decimal 4 spaces to the left. So we have 1, 2, 3, and 4 spaces to the left, filling in those empty spaces with zeros. Again, 0.000603 is our answer. Notice there's no negatives involved, even though the original exponent was negative. Let's try another one. 1.45 times 10 to the negative 7th is 1.45 divided by 10 7 times, for a final answer of 0.000000145. Notice that there are only 6 zeros after the decimal point, not 7. So one common misconception is that the exponent is how many zeros you add to the beginning or to the end, but that's not necessarily true. When we move the decimal 7 spaces to the left, the first place value is taken up by the 1. So then there's 6 more to go that we will fill in with zeros. Take a minute to pause and try these on your own. Count the zeros carefully to make sure that you have the correct number of zeros. As you can see, scientific notation can really shorten some of these really big or really small numbers, and that is the purpose. It's not meant for numbers that only have a few place values. It's meant for these really big or really small values. Second part of this video, we are going to go in the other direction. So we're going to take a standard form number and turn it into scientific notation. When you do this, you need to ask yourself the following questions. 1, where does the decimal point need to end so that that first number is between 1 and 10? 2, how many places does the decimal point move? And 3, should the power be positive or negative? So let's try a few examples. If I start with 12,000, where would I need to put the decimal so that it is greater than or equal to 1 but less than 10? It would be between the 1 and the 2. How many places does the decimal need to move to get there? In this case, that would be 4. Will this exponent be positive or negative? In this case, it's positive because my original number is a large number. It's not a decimal, it is a big number. So this means our answer would look like this. In scientific notation, 1.2 times 10 to the 4th power. Let's try this next one. Where would the decimal have to go to put that number between 1 and 10? 4.56, so between the 4 and the 5. How many decimal places does it have to move to get there? That's 5, and in this case, our exponent is negative because we start with a small decimal, less than 1. So our answer is 4.56 times 10 to the negative 5 in scientific notation. Pause and take a moment to try turning each of these standard form numbers into scientific notation. One last question: if the world population in 2025 may reach 7.84 times 10 to the ninth people, this is about 3 times the world population in 1950. What was the world population in 1950? To solve this problem, we're going to divide the 7.84 times 10 to the ninth by 3. Here is a few extra practice problems to try.